Welcome the grade 11s. We are still continuing with this gen tutorial that we have, and we are now in part 6, and this is what we have. We will just see how far this will lead us. So we will be working entirely with this. Very important that we understand this. Now part 6, the very first problem that we have: determine the nature of the roots of x squared plus 9 is equals to 0. Now remember, the nature of the roots will be the values of x, because we have an x variable there that satisfies a given condition. So meaning we will solve for x here. X squared equals minus 9, and then x equals the square root of minus 9. And because we have the square root of a negative number, the roots will therefore be non-real, because the square root of a negative number, it's a non-real number. So the roots are non-real. Or we can say that the discriminant is less than 0. That's another way. So meaning when we have x squared plus 9 equals 0, we can calculate the discriminant, which is b squared minus 4ac. And do not forget that when you have x squared plus 9 equals 0, this will be a. We don't have b because we don't have maybe 2x, but we have the value of c. So we don't have b, so the value of b would be 0 in other words. So you will have 0 squared minus 4 into a into c. Very important. 0 minus 18 plus 18, 6 carry 1, 36. And what is 0 minus 36? Minus 36. And when you take the square root of this number, you get a non-real number. So please be careful here. Do not solve for x, because you are looking for the nature of the roots. Rather go for calculating the discriminant, because you know if the roots are non-real, the discriminant is less than 0. So meaning this is less than 0. So meaning the discriminant should be less than 0. And what is the discriminant? It's this. Your b squared minus 4ac should be less than 0. And what did we find there? This. Minus 36. And is this less than 0? Yes, any number that is less than 0, it's a number that is negative. So we would therefore say the roots in here are imaginary, or the roots are non-real. Very important that we understand that. Don't do it in this way. Rather go by calculating the discriminant. Why? Because they say determine the nature of the roots. They are not saying solve for x. So here you have solved for x. Here you have found the nature of the roots. Alright, let's go to the second problem. Determine the value of k for which the equation x squared minus 3x plus into k plus 1 equals 0 will have real roots. So here the roots are real. So we know that for real roots, the discriminant is positive. So what we can do there is the following. Now when we are here, if the roots are real, that means we get a positive number. That number can be 0, that number can be bigger than 0, as long as that number is a positive number. So determine the value of k for which this will have a real root. So let me just rewrite this: x squared minus 3x plus k plus 1 equals 0. Now we need to determine a, b, and c. So this would be a, b, and the entire this would be your value of c. So the discriminant is equals, which is again minus 3. Remember they set the values of k, so you will only take the coefficient of x. The value of a is 1 and the value of c is k plus 1. And remember what we are saying. We are saying the discriminant has to be positive. So we therefore saying the square root of there's a 2 there, 9 minus 4 into k plus 1 should be a positive number. And when we are in here, we can just do this, square both sides sorry, and we will have 2 and the square root would go once into each other. 9 minus 4 into k plus 1 being positive. And from here, what I can do is to take this to the other side. That would become minus 9 if it goes to that side. I can decide to divide by minus 4. That would also be fine, but remember it would alter the direction of this inequality. So here I have my k plus 1 because this into this goes once, but the direction would be changed. 9 divided by 4, take to the other side, 9 divided by 4 minus 1. That would be the value of k. So this is what we have, right? That is fine. For 2.1 we can go to 2.2. right? Determine the value of k for which this will have one real root, that is equals to 1. So meaning we are given the value of x, we have to find the value of k. So remember we have x squared minus 3x plus k plus 1 is equals to 0. So we are given one root that is equals to 1. So where we see x, we're plugging in the value of 1 so that we can find the value of k. And again in here they are not specific as to whether the roots are real, equal, rational or irrational. They are just saying one root equals to 1. So when you look in here, I want to take your attention here. I don't have a calculator with me, but I don't know what answer you will find here. Let's just try to look very fast. 9 over 4 minus 1 over 1, you would get 9 minus 4, which is 5 over 4. So meaning the roots there are real and irrational, because this is not a perfect square. So the roots here will be the value of k as that number of 5 divided by 4 would tell you that the roots are real and irrational. So in here, let's plug in the value of 1. So I'm removing these brackets because there's no number here that has to multiply in this. That is why I am removing that. Okay, where did I get equals to 0 now? Sorry. So determine the value of k for which the equation, okay, sorry, this is the equation equals to 0 from the original, and we're not going to use the discriminant here because they are not saying whether the roots will be real or rational. They say one root is equals to 1. So when I'm here, I will have 1 minus 3 plus k plus 1 equals to 0, and I will have 1 minus 3 is minus 2, minus 2 plus 1 is minus 1. So minus 1 plus k equals 0, and k is equals to 1. So if 1 root equals 1, the value of k is also equals to 1. And we can check if this is true. You will have 1 plus 1 plus 1, which is 3 minus 3, which is 0. So that would be in that order. And then in number 3, they say show that the equation x squared minus px minus p squared equals 2 has 2 real and unequal roots for all real values of p. It must have 2 real and unequal roots for all real values of x. So the roots are real and unequal, right? So we are therefore going to say the discriminant has to be positive because the roots are real and different. So the discriminant should be positive. Show that the equation has a real, okay, that is fine, for all real values of p. Now let me just rewrite this. X squared minus px minus p squared is equals to 2. Take to the side. And then from here, let's see what we can do. Remember, we require the values of p. So this would be the value of a, the value of b, and this would entirely be the value of c. So the discriminant has to be positive. B squared minus 4ac bigger than 0. The value of b is minus p, that is squared. The value of a is 1. The value of c is minus p squared minus 2. And this has to be bigger than 0. And then from there, this would be p squared minus 4 into minus p squared minus 2 bigger than 0. I can just square both sides. P squared minus 4 minus p squared minus 2 bigger than 0. I can remove the brackets by multiplication. Plus 4p squared minus 8 bigger than 0. These are like terms. 1 plus 4 is 5 bigger than 0. Take to the side. Very good. Divide. You want to find the value of p, square both sides. Which is the same as this. So remember they said show that the equation has 2 real and unequal. Yes, this is a real and unequal, because remember the square root will always give you 2 answers. So p has to be greater than plus or minus the square root of 8 over 5. So you will have a positive 1 and a negative 1, and these are real and they are unequal because you have a positive and a negative. So that is that. Right, let's see number 4. The coefficients of a quadratic equations are rational numbers, and its discriminant is that. Describe the nature of the roots if the equation describe the nature of the roots of the equation if k is equals to 6. So we are given the discriminant, which is 2k into 2k minus 9. Right, that is fine. Describe the nature of the roots of the equation if k equals 6. 2 into 6, 2 into 6 minus 9. Let me do this. And I would get 12 into 12 minus 9. This is 3. And then I would say 12, how many of them? 3 of them. 6, 3. That would give me 36. And the square root of 36 is plus or minus 6. So the roots, the square root of 36 is 6. So the roots are real, because this is a real number, and rational, because this 36 is a perfect square. So the roots are real and rational. That's exactly what is happening here. Right, and then from there we can go to number 6. No, we can go to number 5. And in number 5, if 5 is one of the roots of the equation x squared plus kx minus 15 equals 0, determine the value of k and the other root. If 5 is one of the root of the equation, so where we see x, we will be substituting 5 and then finding the other root, which is k. So I would take my 5, square that, equals to 0. This would give me 25 plus 5k minus 15. What is 25 minus 15? It's 10. So 10 plus 5k equals 0 minus 10, and k is equals to minus 2. So right, so if 5 is one of the root of the equation, determine the value of k and the other root. So I have found the value of k, and let's see the other root. So x squared minus 2x minus 15 equals 0. The discriminant, b squared minus 4ac. That would be minus 2 squared minus 4 into a into c. And this would give me 4 plus 4 times 15. 15 plus 15 is 30, plus 30 is 60, which is the square root of 64. Is 64 a perfect square? Let me check very fast. The square root of 64. Eight. Yes. So we check. They said if 5 is one of the root of the equation, determine the value of k and the other root. Right, so when k is minus 2, we get 64, which is 8. This is the other root, so meaning the roots are real and rational, because this is a perfect square, this is a real number, therefore the roots are real and rational. Because they said 5 is one of the root of the equation, where we see x, we plug in 5 and then we get the equation. From the equation we find the other root. There would be that root. Right, in number 6, given that f at x is equals to 3x squared minus 6x plus m, determine the value of m if f at x equals 0 has non-real roots. So if non-real, the discriminant is negative, and f at x equals to 0. So we're going to say 0 is equals to 3x squared minus 6x plus m. So they say determine the value of m. So meaning the square root of b squared minus 4ac is less than 0. And we need to find the value of a, b, and c. Now remember, we have 3x squared minus 6x plus m, that is equals to 0. This would be a, b, and c. So I would say minus 6 squared minus 4 into a into c. And this has to be less than 0. This would give you 36 minus 12m, that is negative. You square both sides. 36 minus 12m less than 0. Take to the other side. 36 less than 12m. From here you would find that m should be less than 36 over 12. You can just insert this on a calculator for simplification purposes. So if m is less than 36 over 12, you will have imaginary roots. Okay, that is fine. I'm not going to do number 7, 8, and 9. I will leave that for you to enjoy. So thank you guys. If you liked this tutorial, please do share, like, and subscribe, and I will see you in part 7. Welcome wonderful people, the grade 11s. This is Mr. Ndabezita once again, and we are now, remember, we are still continuing with the gen, and we will be doing let me check. I think we should complete number 8. We are still in part 7 and we will be dealing with number 8. So in number 8, let me just do this. Part 7, number 8. They say to us now, given that m plus 1 divided by m is equals to 3. In 8.1 they say determine the values of m squared minus 1 plus 1 divided by m squared. So this is the value that we need to find. M squared minus 1 plus 1 divided by m squared. And we ask ourselves, when a problem of this nature is provided, what is the first thing that we need to do? So let me just draw up a line. Let me just put this aside so that we can see this more clearly. All right, we're going to take that which is given. So let me just say solution. So we're going to take m plus 1 divided by m, that is equals to 3. And what we are going to do here, we are going to square everything, because we want to have m squared plus 1 over m squared. So what we are going to do is to square everything in here. So I'm going to say m square that 1 over m square this equals 3 squared. I'm squaring everything that I have in there, and this would be m squared plus 1 over m squared. Remember, 1 squared is 1, m squared equals 3 squared. That will provide you with 9. So we have m squared plus 1 over m squared is equals to 9. Something very much worthy of noting. And if you check this, so meaning m squared plus 1 over m squared is equals to 9. This is something very important. M squared plus 1 over m squared is equals to 9. So where we see m squared plus 1 over m squared, we're going to write 9. So let's try to rewrite this. So we're going to say m squared plus 1 over m squared minus 1. Have you seen what I have done here? I just rearranged this so that I can see that this is equals to that. So where I see this, I'll be writing 9. So this is 9 minus 1, which is equals to 8. Something very important to note. In 8.2, they say, hence determine the value of M3 plus 1 over M3. Right, the very same thing needs to transpire in here. We can take that which is provided to us, which is this. We can just say, okay, solution. We can say M plus 1 over M is equals to 3. Now, instead of squaring all this, I'm going to take the exponent of 3. Very important. So this will be M3 plus 1 over M3, because 1 to exponent 3 is 1. This is M3 equals 27. So where I see this, I'll be writing 27. So there it is provided for me. So I'm going to say 27. The answer for this is 27. There we are. Something very important for us to see there. Right, and then from there we can move on to part 8. Let's go and look at part 8. Right, they say I'm not going to deal with solve for x, because we have dealt with this so many times. I just want us to look at number 1.4. So 1.4, they say the roots of a quadratic equation are, and we are given x is equals to 3 plus or minus the square root of minus k minus 4 divided by 2. And they say for which values of k are the roots real? For which values of k will the roots be real? Now remember, if the roots are real, the discriminant must be greater or equals to 0. That is to say, those roots are real. And they say for which values of k will make this to have a real roots. So meaning those roots, if they are real, they can be equal, they can be rational, they can be irrational, but they shouldn't be less than 0, meaning they shouldn't be non-real, because we are told that the roots are real. So what value do you think we should substitute where we see k that will make the whole of this to be a real number? So let us try to look into this. So we're going to say, okay, x is equals to 3 plus or minus. So let's take in, for example, we know that whatever that is under the square root, in order to have real roots, must be positive. This is very important, because what is inside of the square root, if it is negative, therefore the whole expression, the whole equation becomes non-real. So we need to find the values of k such that whatever that is under the square root becomes positive. So I'm going to have minus, and so the value of k that I should think about, it's a value that is negative. So that negative by negative is a positive. So I'm going to have a negative value here. And that value that I'm thinking about should be a value that is less than minus 4. This is very, very important. So I'm going to take, for example, minus 5. And then I'm going to say minus 4. Look what is happening here. I have the negative. There it is from the outside. I'm choosing a value of k of minus 5, minus 4, and I am dividing this by 2. Let's see what will happen. 3 plus or minus, negative by negative is positive, divided by 2. So I'll have 3 plus or minus the square root of 1 over 2. If you take the positive 1, you will have 3 plus 1, because the square root of 1 is 1, over 2. That will give you an answer of 2. and then if you consider a negative, you will have 3 minus the square root of 1 over 2. That will give you 3 minus 1, which is 2 over 2, which is 1. So in this case, because what we have inside of the square root is a perfect square, therefore the roots are real and they are rational. This is very, very important. The roots are real and rational, since what we have inside of the square root is a perfect number. So this is one way of looking at this. Somebody might choose a value that is different as long as the roots are real. They are not very specific as to say those roots should be real, rational, irrational, unequal, and so on. They should just be real. So in this case, we have chosen a number that makes the roots real and also rational. So there are no restrictions that are provided for us in this one. Right, be that as it may, let's move on to they have question 1 in here, and I'm not going to deal with all of this. I'm just going to be very selective, so I'm not going to deal with this. Let me show you. I'm not going to deal with 1.1.1, 1.1.2. I'm going to deal with 1.1.3, 1.1.4, 1.1.5, 1.2, and 1.3. So meaning 1.1.1, 1.1.2, that would be for you to do. So I'm just going to deal with this part, only this part. Right. Let's dive into this. So in question 1, we have the following. They say solve for x, and we have in 1.1.3 they provide us with 2x minus 5 over 4, and this is equals to 64. And this is going to be very problematic because I don't have a calculator with me. I don't know how I am going to do this, but let me just have a pause, try to grab another cell phone so that we can work in this. Right, so let me just go to this cell phone and find a calculator that might do the work for us. So here it is, and from here what I will do in here, because I'm looking for the value of x, I'm going to divide everything by the coefficient of x, which is 2. That is the first thing that I need to get rid of. This into this goes once. X negative 5 over 4 equals 64 divided by 2. That should give us 32. Right, and then from here, because you are looking for the value of x and you have a number on the side with an exponent of 1, you're going to multiply both these exponents by the reciprocal of minus 5 over 4. So that is to say minus 5 over 4 times minus 4 over 5. That would be the reciprocal of this. And what you do on the left, you also go and apply on the right. Very, very important. This into this will go once, and you will be left with this, which is 32 minus 4 over 5. So unfortunately, I don't have a calculator that might be able to work this out, but let me check. I think 32 has to be 2 to an exponent of I think 5. Yes, 2 to the exponent of 5 multiplied by negative 4 over 5. Denominator numerator goes once. 2 minus 4, which can be rewritten as 1 over 2 to the exponent of 4. If you want to make this positive, I will assume you have learned this in grade 10, and that should give you 1 over 16 as the value of x for that. Right, I think we are correct in this, and if we are not, it's your responsibility to go and check. Right, let us continue in this. Let us continue in this. 1.1.4, we have the square root of 2 minus x equals x minus 2. So this is what is provided. The first thing to be done here is to get rid of the square root. How do we do that? We square both sides. 2 and the square root goes once. I will assume you know what really transpires for that to be possible. 2 minus x, we're going to repeat this 2 times. Right, 2 minus x, remove the brackets using the distributive law. X squared minus 2x minus 2x plus 4. 2 minus x, x squared minus 4x plus 4. Take these ones to the other side. Write these ones first. Take this to that side. Take this to that side. Very good. There, try to do things nicely. You have your x squared minus 4x plus x is minus 3x plus 2. Remember your 0. Factorize all this. X and x, 2 is a prime number. The bigger number takes the sign of the middle term. This is negative, because negative times negative is a positive. Minus 2 minus 1 is minus 3. So this equals 0, or that is equals to 0. 0 equals x minus 2, or 0 equals x minus 1. Take to the side, this is x. Takes to the side, this is x. And then you need to go and check between which ones of these are really the solution for that, because you have a square root. I'm going to leave you for that. I'm not here to spoon feed you everything. It's your responsibility to go and check which one is the solution for that problem. As in belief. Right. Moving right along. 1.1.5. We have x squared plus 7x being less than 0. Very good. Now we are dealing with an inequality sign here. So what we are going to do here, when we are in here, we just find the critical values, so which we call the CV. How do you find the critical values when you have an inequality like this with a 0 on the side? You just make this equals to 0. So you just say x squared plus 7x equals to 0. You can factorize in here. X plus 7 equals to 0. And then from here, remember, x times x is x squared. X times 7 is 7x. This is good. So x is equals to 0, or x equals to minus 7. And then from there, you draw up a table of values moving from negative infinity is to positive. And then from there you will say, I'm moving from negative infinity to minus 7. Minus 7 and 0, and then 0 is to infinity. We have dealt with this, wonderful people. We have dealt with this. It is your responsibility to go back and check the tutorials of Papa Fanzo. Now from here, we just have to draw up a table of values. Forgive me for that N2 mathematics work. So let's try and look into this. Now remember, we have a table like this, where we having minus 7 and 0, negative infinity, minus 7, minus 7, 0, 0 is to infinity. Right, from here we draw up a table. So we will write our negative infinity minus 7, 0, 0 to infinity. Very good. And then from here, a value that is less than minus 7 is minus 8. A value in between minus 7 and 0, we can even take minus 1. A value that is bigger than 0, we can even take 1. And then here you write your equations. This is what you write. your x, then your x plus 7. So here you will have your x plus 7, and the multiplication of those two, right? And then from here, what is it that we can do now? This will be minus if you substitute, minus if you substitute, positive. If you substitute in here, you will have minus, positive, and positive. And then the multiplication of the two, positive, negative, positive. Now you go and check. They said where this is negative, right, less than 0. So where is that? Here. So your solution is minus 7 is to 0, and they are both exclusive. Why? Because this is a less. If it was less or equal, we would include making that square bracket. So if they are not inclusive, we make an open bracket. So that becomes your solution. Alright, wonderful people. Let us just try and complete 1.2 and 1.3. So in 1.2 we are given, and that which is given is the following. We are told that 3x minus y squared plus x minus 5 squared must be equals to 0. So when we find the values of x and y and we substitute them in here, the equation has to be equals to 0. So that left is equals to right. Now if I was somebody, the first thing that I would do was to say, okay, let me try and introduce the square root in everything. So somebody would say, which is me, I would say 3x minus y squared plus x minus 5 squared equals 0 square root. This is the first approach that I would have. 2 into this goes once, 3x minus y plus this into this goes once, x minus 5, the square root of 0 is 0. Grouping the like terms, 4x minus y minus 5 equals to 0, and this doesn't get me anywhere. It doesn't really get me anywhere. So how do I do this? Because they say solve for x and y. So the first method fails, and I will try to employ the second method. So I would copy down the original problem. Right, and then what I would do here, I would try and say, okay, let me repeat this 2 times because they are squared. So I would have 3x minus y, 3x minus y, x minus 5, x minus 5 equals to 0. Remove the brackets using distribution. 9x squared minus 3xy minus 3xy plus y squared plus, I know this is x squared minus 10x plus 25 equals to 0, because you would have x squared minus 5x minus 5x, which is minus 10x plus 25. I would try and group the like terms. This and this would give me 10x squared. This and this would give me minus 6xy. And then what else do I have here? I have my y squared. I have my minus 10x. What else do I have? Plus 25. that is equals to 0. Let me check if everything is correct. I have this, I solved for those, I wrote this. I forgot to write the x squared. Minus 10x, there it is, and 25. All right. No, not this, because remember we said 9x squared plus x squared, it's 10x squared. So I will arrive to something like this, and what will I do here? There seems to be no solution for this one as well, so the second method would also fail. I can't seem to find x and y simultaneously, so I would try the last method. I will copy down the original, now because this is a squared plus this is a squared and they are equals to 0, both of them, what I can just simply say in here is just to say let 3x minus y be equals to k and x minus 5 be equals to p. So where I see 3x minus y, I will write k, so I will have k squared plus p squared, that is equals to 0. So when it is like this, I can say k squared equals to 0 or p squared is equals to 0, because their sum equates to 0. So I will substitute k with 3x minus y equals to 0 or x minus 5 equals to 0. I can solve this one first because there's only one variable, x is equals to 5, and I can substitute it in here in order to find the value of y. So I can say 3 into 5 minus y equals to 0, take to the side, 15 is equals to 1. And I can check if this is correct. I can go to the original, 3x minus y squared plus x minus 5 squared, that is equals to 0. I can substitute the values. I can say 3 into 5 minus 15 squared, and I can say 5 minus 5 squared, and see if this will be equals to 0. I will have 15 minus 15 squared and 0 squared, and this is 0 squared plus 0 squared, which is equals to 0. So that would be the values that I find. X is equals to 5 and y is equals to 15, and when I plug those values exactly the way in which they should be plugged, I get 0. Somebody might try a different approach, but this is very correct because the left hand side is also equals to the right hand side. No stress about that. Let's go to 1.3. In 1.3, they say for which values of k will the equation x squared plus x equals to k have no real roots. So if the roots are not real, they must be imaginary. So therefore the discriminant, the delta of the equation, has to be less than 0. Meaning what we are saying is the value of b squared minus 4ac, or the value under the square root, has to be negative. Right, so the first thing we do is to rewrite this. We can say x squared plus x, take to the other side, equals to 0. We identify the values of a, b, and c. Obviously this is a because the coefficient of x squared is a, and then the coefficient of x is b, and any other thing that is left becomes the value of c. And then from here we can proceed to plug in there b squared minus 4ac less than 0. So you will have 1 squared because that is the coefficient of x, minus 4a, it would be 1, and c is minus k. This has to be less than 0. So you have 1 plus 4k less than 0, because negative and negative will give you a positive. Take to the other side. For k less than minus 1, divide by 4, divide by 4, k is less than minus 1/4. So what is this? This is imaginary. This is imaginary. So for which values of k will the equation have no real roots? We will have no real roots when k is less than 1/2. And be very careful that in here minus 1.25, it's not part of the solution, because the inequality says less, not less, and equal. So meaning we are accepting any values that are less than this. Which values are those? All those values going to negative infinity, we accept them except at exactly minus 1.25. This is very, very important that we see it in that light. Right, so that would bring us to the end of part 8, and I will see you in part 9.